Now, for today, all right, I want to first look at what we did last night. All right, somebody said they had some issues. All right, so on this worksheet right here, what am I looking at? Go, tell me. Let's look at number 9. All right, now, honestly, when I look at these, I just identify long leg, short leg, and hypotenuse. That's what I do. All right, so right now, if I'm looking at the big triangle, right, I know that I have a short leg and a hypotenuse. Everybody agree with that? So I can say 10 over 20, and I just write short and hypotenuse. All right? Now, 10 is right here. This is also the hypotenuse of the smallest triangles. Everybody agree with that? So if that is 10, then the short leg would have to be what? 5. That's how simple that is. That has to be 5. And then x automatically has to be what? 15. There you go. Emily, how am I doing? You got that so far, though? All right. Now, the only thing I'm missing is what? Is z. So right now I can say I have 15 over z. So if I put 15 over z, that is a hypotenuse and a long leg. So now I need a hypotenuse and a long leg. So my hypotenuse is 20 and my long leg would be z. How's that? And so now I have z squared is equal to 15 times 20. Of course, we're not going to multiply that out. We're going to see that z in here is 5 times 4. So that makes a common 5 times 2 times radical 3, which is 10 radical 3. All right, that'd be really nice if you understood what I just said. All right, does anybody have any questions with how I did 15 times 20 and broke it down to 10 radical 3? What?
I just feel like solve it first, but like I just did like.
There's lots of ways to do it.
Like I didn't get the right answer.
Well, then that way was not correct. Then. Seriously. All right, of course. But again, I'm, and this is what I'm saying. I don't mind if you're incorrect. I'm just saying, does that make sense now?
Yes.
Right? That's what I want you to be able to do. All right? Identify 2 parts of the triangle that are known. All right? And then try to make that a proportion. What? Let's look at number 8 now. All right, come on now. So from my strategy, you see I would just do 2 over 3. All right? So if I did 2 over 3, that would be a short leg and a long leg. Does everybody agree with that? Now I'm looking at the triangle on the right. What's the short leg? And what's the long leg? There we go. So 2x equals 9, x equals 4.5. And I just did 4.5 because I knew I was going to get z, which would make that what? 6.5. How's that? That wasn't bad, right? Come on, that's what I'm saying. You guys got to practice now. You can't let me do the work. I don't think that was that hard, right? Now I need to find y, right? Well, y, because we're brilliant, I could just say, well, that's 2 and that's 3, so we already know that's just the square root of 13 and be done. You see how I got that so fast? A squared plus b squared equals c squared. You agree now? Right? You can always do a squared plus b squared equals c squared. Sometimes it's easier just to do a squared plus b squared equals c squared than to try to do the what? The proportions. All right, pretty soon we're going to be doing trig, which means you don't even need to do any of this because you can use trig to solve all these problems. All right, so again, I just don't think that's that bad. All right, does anybody have any questions with that? All right, use Pythagorean theorem if you can. All right, if you see it. Easy. What? All right, let's look at 10. Let's see what it says here. An airport, a factory, and a shopping center are the vertices of a right triangle formed by 3 highways. The airport and the factory are 6 miles apart. Okay, so I'm assuming, all right, I'm just going to make a right triangle, and it might be wrong, but I assume it's going to be right triangle. Right, and an airport, a factory, and a shopping. Oh, it does say vertices of a right triangle. So the airport and the factory are 6 miles apart. The distance from the shopping center is 3.6 and 4.8. All right, so so the longest one is the airport and the factory, right? So that would be 6. And the airport is distance from the shopping center. Oh, so we're talking about from the airport, right? So the best thing is the airport to the shopping center is 3.6. The airport and the factory, and so I'm assuming this would have to be 4.8 then. Do I agree with that? Does that make sense? Anybody? A service road will be constructed from the shopping center to the highway that connects the airport and the factory. What is the shortest possible length? So it has to be what? Perpendicular, do you agree? That'd be the shortest. Does everybody agree with that? So now I'm just looking for this right here, right? Now someone was saying about 3 variables. What are we thinking about here? Tell me, did you know?
Do like 6 squared. That one.
Well, yeah, no, because
yeah.
because it's partial, right?
Yeah.
So that's the whole thing. From here to here is 6. All right. The first thing I would do is I would just put x over 3.6. I don't know, right? I could be wrong. All right. So I'm just going to put x over 3.6. And so x is, it looks to me like the long leg, and 3.6 is the what? Hypotenuse then, right? So on the big one, what's the long leg? 4.8, right? Then the hypotenuse is what? Yeah, I think that's it right there. Does everybody agree? Does everybody see what I'm saying about I knew I needed x, so the only part of that triangle that was left was 3.6. All right, hopefully that makes sense. And I don't care about the answer, just cross multiply divide. Is everybody okay with that? Everybody okay? Everybody okay? Anybody? All right, do I need to do anything else on this? Anything else? Anything else? All right, now look, guys, remember, homework is not optional. All right, homework is not optional. I know you guys got a lot of work. That's why I was fussing at you earlier. Get into class and let me get the work done for you. I'd much rather work with you in class and get it all done. All right, that's why I said get here. I don't want to waste time. All right? I don't want you going home stressing over math, because right now, the math, you have to admit, is kind of easy. All right? Now, today's going to be really easy. All right? So let's flip this over to now 8.2. All right? Download that real quick. Hopefully you already did. And then I'm going to show you how Pythagoras solved this problem. All right, a squared plus b squared equals c squared. Let's figure out how we do that. All right, so let's look. I went ahead and just added it to your paper, right? You have that up there on yours too? All right, I just drew this out. All right, so what I tried to draw here are 2 squares. All right? Come on now, look up. You're not going to be expected to repeat this. Most people can't, but it's very elementary. All right, these are just 2 squares. All right, 1 square inside another square. All right, now if you tilt the square, it's obviously smaller. What I'm telling you is this distance from here to here is what? A. And this distance from here to here is what? B. All right. Well, if you tilt it the same way, the same exact length will be down here also. Does everybody see what I tried to demonstrate on that? Does everybody see that? All right. So now, if I said, what is the area of the big square? What would be the area of the big square? How could I write that? Good.
A plus B times 2. Oh, I mean A plus B times A plus B.
Yes. Do I agree with that? The area of the big square is just A plus B squared. Do I agree with that? Any issues? All right. Now, what is the area of the small square? Which is, so I'm going to put C squared right here. Right? So everybody see that? Now, what would be the area of one of the triangles? What was the area of one of the triangles? Tell them.
A times B divided by 2.
Yes, very smart. Area of a triangle, 1/2 AB, or 1/2 base times height. Everybody agree with that? So come on now, right in here, this area right here is 1/2 AB. So what's the area of the other triangles? 1/2 AB. Does everybody agree with that? So if I added all those shapes, does everybody agree that those areas would be equal? So A plus B squared has to equal C squared plus 4 times 1/2 AB. So everybody agree with that? Come on now, this is not that hard. Not that hard, and I want you to be able to, when somebody asks you about the Pythagorean theorem, I'd like for you to be able to see it. All right, it's really, really simple. All right, but it was actually really complicated at the time. All right, does everybody see that? So I just added the area of all the smaller regions. Does everybody agree with that? Everybody see that? So now, does everybody agree that A plus B squared is equal to C squared plus 4 times 1/2 AB? Please, if you don't know that, if you don't understand what I did, please tell me.
Where did you get 4?
Okay, very good question. Thank you very much. There's 1 triangle, 2 triangles, 3 triangles, 4 triangles. You good now, right?
Yeah.
All right, that's good. Anybody else have any objections to that now? So I agree the area of the big square is equal to the sum of its parts. Do you agree with that? All right. Now what I want everybody to do is I want everybody who remembers how to expand A plus B squared. All right, just multiply that out. Everybody multiply A plus B times A plus B. And I'll go slow for you guys. All right, that's what I'm asking. All right, so multiply that out. Give you another 30 seconds. Well, don't blank stare me like I'm asking you like something really complicated with A plus B times A plus B. A squared plus AB plus AB plus B squared. Does everybody see that? And so if I expand A plus B squared, that's A squared plus 2AB plus B squared. Does everybody agree? Anybody have any? That's a good review problem. Everybody okay with that? Equals. Now let's expand or simplify the right side. What does the right side simplify to? C squared plus what? 2AB. Look how nice that is. Everybody see that? So what happens to the 2ABs? So now we have what? That's super, super important. Super nice. All right? Easy. All right? Easy proof of the Pythagorean theorem. All right? A squared plus B squared equals C squared. All right, now we've obviously talked about this a bunch. This is not new. In my opinion, I think this section should be put in like chapter 1 because we've done it so much, but I'm not really showing you anything new. All right, today. I almost skipped it, but I really thought it was a good idea that I show you the Pythagorean theorem. All right, now the next thing in this section is called the triples. And these are the numbers that always occur on standardized tests. And if you remember these numbers, the problems are super simple. All right? So I want you to identify the Pythagorean triples. All right? And these are just the integers, all right, that are common that form a right triangle. The first one, who remembers the first one? We always do this one. 3, 4, very good. 3, 4, 5, right triangle. All right, that's the first triple, 3, 4, 5. And obviously the hypotenuse has to be the 5 and 3 and 4 the legs. Does everybody agree with that? Now, does everybody agree I could also say 6, 8, 10? Right? Because they're just multiples. You agree with that? So 3, 4, 5. Anytime you see a 3 and a 4, you know the hypotenuse has to be what? 5. If you see a 5 and a 4, you know the other one has to be what? There's no reason to do the problem. All right, you will cut out a huge amount of time if you know these triples. And on standardized tests, that's what you're trying to do. You're trying to gain an advantage on your time. So if you know these things, people will be doing the math and you'll be going to the next problem because you know these triples. All right, it's 3, 4, 5. The next common one that you see a lot is 5, 12, 13. That's something I would like you to know. Do I care if you know it? No, because you can always just do 5 squared plus 12 squared, and then you'll get 13 squared. All right? After 5, 12, 13, you're supposed to know 8, 15, 17. That's another important triple. And the last most common, not most common, but the last one that I see on entrance exams is 7, 24, 25. So those are the 4 main ones that you should focus on. All right? If you see a 3 and a 4, you know it's 5. You see an 8 and 15, you know the hypotenuse is 17. It's really, really simple. Really simple. All right? So let's see if you can see what I mean right off the bat. So number 1 is a Pythagorean triple, right? So it would be 15. Thank you very much for that. How did he get that so fast? Because he looked at that and he said 9 is what? 3 times 3. 12 is 3 times 4. So this has to be 3 times 5. Now some of you are hard-headed and you're not going to learn the triples. Do I care? No. It just makes it so much easier. I don't feel like doing 9 squared plus 12 squared equals c squared and then taking the square root of that. I just know the answer. Everybody okay with that now? All right? You know how to do Pythagorean theorem, so it's not a big deal. So let's see if 2. Wow. Right? Does everybody see what I'm saying? It's a waste of time. Know those triples. Save yourself a bunch of time. So x equals what? 5. Everybody good with that? All right, let's check out 3. Let's see if this is a triple. So this is 4 times what?
3.
And this is 4 times, uh-oh, that is not a triple. That is not a triple, which means we're going to have a square root. So keep your eyes up here because I'm going to show you something super nice, super cool. All right, it'll save you a bunch of time if you know this. All right, does everybody understand that was 4 times 3 and 4 times 8? So the hypotenuse is going to have to be 4 times something, right? And of course, because we are brilliant, we can do 3 squared and 8 squared. 64 plus 9 is 73. So the hypotenuse is 4 radical 73. And kids will be going, oh my gosh, how did you get that so fast? It has nothing to do with you being so smart. It's that you understand numbers better than they do. Right? I don't want you to do 12 squared plus 32 squared. And then you have to break down that number. So I agree that would be difficult. Right? On a standardized test, remember, your objective is to be able to work fast and accurately. All right? And that's what we're trying to show you right now. Does everybody see how simple that is? All right, so let's try number 5. Let's see if we're having any better luck. Or number 4. Okay, so here, all right, I don't really like this setup. So watch what I'm doing. All right, please watch. I know that this is 50, and this could be what? 25. Everybody see that? So now they both have, let me see if I can do this correct, 5 over 2 times 5. Does everybody agree with that? Oh, actually, that was really silly. This is really 25 over 2, right? And this one now is really what? 50 over 2. You see what I'm getting at? So now it has a common what? 25 over 2. So this is 25 over 2 times what? 1. And this is 25 over 2 what? All right, so this is 25 over 2 times 2. All right, now this is kind of advanced, so some of you looking at me like, oh my gosh, forget that. I'd rather just do a squared plus b squared plus c squared. I'm okay with that, but listen, I'm trying to show you numbers better. All right, so even if you're not interested, just try to listen. I promise you, your math skills will improve tremendously if you understand what I'm saying. All right? So again, I didn't like 12.5 because I'm not going to do 12.5 squared. So everybody agree with me? So I just changed 12.5 to what? 25 over 2. Then I noticed something. Wow. All right, there's definitely a relationship there. Right? So what I said was that this now has a relationship of 25 over 2. Right, let me see if I can get this right. This is 25 over 2, and this is 25 over 2 times 2. Does everybody agree? Mm-hmm. So now I'm just looking at this answer. See if you can agree with this. Is 25 over 2 radical 3. Does everybody understand where I got the 25 over 2 from? Well, the reason why I got 25 over 2 is because 25 over 2, come on, was a common factor here and a common factor over here. So far, so good with that? Yes or no? And what was left behind? The 2 and the 1. Come on, I like that. So what I'm going to do now is I'm really trying to show you what happened back here. So I'm trying to show you now how I'm going back to something that was so easy, and now I'm going to try to show you why that was easy, and now we're going to apply it to something a little bit harder. All right, so let's look up here. Does everybody agree this was 3 times 4, this was 3 times 3, so the answer had to be 3 times something. Correct? So now we know down here, this was 25 over 2 times 1, this was 25 over 2 times 2, so the other one had to be what? 25 over 2 times what? Something. Times something. Now, I'm not sure why you think it's 3, but all I did in my head was I did the Pythagorean theorem for 1 and 2. What's 1 squared?
1.
What's 2 squared? 4 minus 1. Square root of 3. That's where I got that. All right, so let me look over here just in case you didn't see what I just said. I have a triangle that who has a hypotenuse of 2 and has a leg of 1. Everybody see now mathematically why the other leg has to be square root of 3? Hello? You with me? Because if you did Pythagorean theorem, now, when the numbers are small, I'm expecting you to be able to do the Pythagorean theorem in your head, right? 2 squared is 4. 4 minus 1, square root 3. Everybody okay with that now? All right, so that's where I got this square root of 3 from doing the Pythagorean theorem from that. All right, keep practicing with me. All right, let's go on to number 5. All right, so this is an isosceles triangle. Do you agree? So what happened to the 8 when I drew the altitude? What's this? That's right, so this is 4. Thank you. So now you got to do some mental math here. What's 9 squared?
81.
What is 4 squared?
16.
So now I have to do 16 minus 81, or 81 minus 16 because I have the hypotenuse, correct? So 81 minus 16. Now here's how you should be doing 81 minus 16. 81 minus 10 minus 1 minus 5. 65. Does everybody agree with that? Some of you, I don't know what you're doing, but that's okay. So that's the square root of 65. Does everybody agree? And if you want 65, check yourself plus 16. That should be what? 81. Some of you guys, your mental math is a little weak. So we're trying to make it better. Try to do the mental math in your head. Tonight, I don't care if you use what? Calculator. Try to practice right now, mental math. What?
So why did you minus 16?
Isn't 4 squared 16?
Yes, but why did you subtract it?
Because the hypotenuse is what? 9. We're finding a leg.
So you do.
A squared plus B squared always equals C squared. Thank you for asking me that. A squared plus B squared equals C squared, true?
Mhm.
So I have a hypotenuse and a leg.
Yep.
So to find the other leg, I subtract them,
Subtract it.
right? See me now. All right? So that's what you're trying to identify. If you have two legs, you just add them and take the square root, right? If you have a hypotenuse and a leg, you do what? Subtract them and then take the square root. Does everybody hear me? Come on, this is simple, simple, simple. Just a little bit harder with the mental math. All right? Please practice. Don't just let me say everything. All right? Say it to yourself as we're going. All right, let's move on. Number 6. Now this one I don't think there's any hope for on this. Does everybody agree? Is that a triple? No. So I don't really have any hope for you on this one because there's nothing common with 31 and 14. Does everybody agree? So we got to do 31 squared plus 14 squared. Just do it on the calculator. 31 squared plus 14 squared. And tell me what that is. Say it again. 1,157 square root x equals. And I'm trying to see if there's a perfect square hidden there somewhere. All right, I think you're right. I don't see anything. All right, so that was kind of silly in my opinion. All right, so now let's go on. Now here they're saying that use the triples. All right, so here we go. 7 is what?
13.
13. All right, here we go. 6. Good job, guys. All right, over here, what's common?
4.
4. Right, so this is 4 times 3, 4 times 5.
16.
Yeah, guys, come on. Good job, 16. Everybody with me? Come on now, speak up. What? Because do you see that these two had a common factor of 14, right? I mean, a common factor of 4. So this one has to be a multiple of 4 also. Right? And then we know that the triple is 3, 4, 5. Easy enough? 16. Good. Thank you. All right? Easy enough. Everybody agree? All right, let's knock out 10. So 5 times 5, 5 times 13, right? So we know 5, 12, 13, right? So thank you for saying 60. That's what you should be able to do. All right. Everybody happy with that? I agree. All right, look over here. What do we have? How'd you get that, kiddo? Good job, girl. 8 times 3, 8 times 5, 8 times 4. Very good. 32. Easy, easy, easy. All right. All right, what about 50 and 48? 2 times what?
24.
And 2 times? So look up. It was what? 2 times 7. Thank you. So that's what? 14. Easy, easy, easy. What? I looked at my triples. 7, 24, 25. See what I'm getting at, right? All right, very good, guys. I think so anyway. All right. So now, for some reason, I've never really seen this on a standardized test, so I don't think it's that important. I just think it should be known, though. All right, so I want everybody to look up here for a second so I can show you something. Right, here's a right triangle. You've got to visualize this. Look how simple this is. A squared plus B squared equals C squared. Does everybody see the hypotenuse? If I extend the hypotenuse, what does that happen to the right angle? Makes it obtuse. So it's obtuse if what? If C squared is what? Greater than A squared plus B squared. Like I said, I never understood why that was a difficult thing. Everybody see that? If I shorten the hypotenuse, what is that doing to the right angle? Makes it acute. All right? Do you agree with me? So that means then that C squared would be what? If C squared is less than A squared plus B squared, it is what? Acute. If c squared is greater than, it would be what? Obtuse. And of course, if it's equal to, then it would be what? It would be right. All right, so that's how you can tell. All right. Now, it says determine whether each numbers can be the measures of the sides of a triangle. All right, so you had to remember that in order to be a triangle, the sum of the two smaller sides has to be greater than the third side first. All right, I said that quickly, so you got to listen to me. In order for you to have a triangle, the sum of the two smaller sides has to be larger than the third side. Everybody agree? All right, so now let's look through these real quick. Is 13, well, we can just say that's automatically what? Right. Now, is 8 plus 14 greater than 20? So that's a triangle. Yes, that's a triangle. Is 12.5 plus 13 greater than 26? No, so that's not a triangle. You're going to make a mistake on the test if you don't test first to see if it can be a triangle. Everybody okay with that? All right. Now, here, 3 square roots of 2. Well, and I don't know. Square root of 2 is 1.414, so 3 times that is already greater than 4. So, yes, that's definitely yes. All right, 21 is greater than 29, so that's a yes. 32 plus 35 is what? No, not a triangle. So the only ones you have to do are 14, 16, and 17. Is everybody happy with that? So, what is the relationship between 4 squared? Well, let's just do the mental math. Come on, guys. Put your eyes up on the board. Let's do the mental math. What is 4 squared?
16.
Okay, so I'm comparing 16 to, now I need help with 3 radical 2 squared. What's 3 radical 2 squared? Everybody?
6 squared.
No.
9.
Which is? Stop. 9 radical 4. Stop.
18.
18. Thank you. It's 18. All right. So how do we do that again? Come on, guys. Everybody should be able to do that. 3 radical 2 squared. Come on, practice. What's 3 squared? Now, when I say radical 2 squared, you're not going to tell me radical 4 anymore. You're just going to tell me that's what?
2.
2. Do I agree?
Mm-hmm.
So 3 squared is 9. Radical 2 squared is
2.
2. 9 times 2 is
18.
18. And then square root of 7 squared. So automatically we would say it is what? It's a cube, right? Uh-oh. I made a mistake. Because 3 radical 2 is bigger than what? 4. Hear what I'm saying? 3 radical 2 is bigger than 4, correct? So I got to fix it. All right, so I'm really comparing what? This guy is the biggest. This guy is smaller. So it's still what? I was still right. You know I'm wrong. Is that kind of nice? All right, guys, that was a pretty good joke. All right. Now you got it. All right, good. All right, here we go. So now let's check out number 14. So I have what? We're comparing 20 squared. Everybody knows what 20 squared is? 400. All right, we all know what 8 squared is. That's what?
64.
And of course, we all know 196, right?
Yes.
So 400 in this case is what? We don't have to do the math. 400 compared to 64. Right? You understand me or not? No, come on now. Listen, this is what I'm trying to get some of you to avoid. You're going to go to high school, and you're going to be around a bunch of people, and no one really cares how smart you are. So when you don't understand something, you got to say something. Don't sit there. All right? That's part of being smart, is asking if you don't know. All right? Is everybody sure that 400 is greater than 64 plus 196?
Yes.
So it is what?
Obtuse.
Obtuse. Here we go. Obtuse. All right, so let's look at the next one. So now we're checking 29 squared. Somebody said 841. Yes, it is right, actually. All right. So that's 400 plus 441, right? And they're equal. So it's a right triangle. So that's another triple. All right, 20, 21, 29, but they don't use that. All right, guys. That's a good day today, man. Very good day. Hopefully you feel a little better about your numbers. Again, if you didn't like the numbers, that's okay. You can use your what? You can use your calculator, but a lot of times your calculator is just a waste of time. All right, a waste of time. So your job now, tonight, please give it a shot. 8.2. All right, give that a shot. Now, also, leave the square root. We're not doing decimals. All right, we're not doing decimals. Everybody agree with that? All right, so if I'm looking at number 1 right off the bat, that's kind of silly. So x is equal to the square root of 13 squared plus 23 squared. All right? Easy. All right, you guys finish up now.